If you recall, on Thursday, we're going to have our first practice test. I've got a practice version of the practice test, so double practice. And I just want to talk about some strategies and clarify what we mean on some of the instructions that you will be given. So let's take a look at this. So first of all, the first problem is going to look just like this. It's going to be solve the right triangle, show your calculations, round your answers to 3 significant figures. And then I'm going to give you the toolkit in kind of this, this typed form. This is exactly the toolkit that you will be given. I'm just going to be modifying this to make the practice test. So I'm going to tell you that angles A and B are complementary. That is, A plus B is equal to 90. I'm going to tell you that A squared plus B squared equals C squared. That's the Pythagorean theorem. And I'm going to tell you that sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. And tan of theta is opposite over adjacent. The tricky thing about here is that I phrase the trig ratios in theta because they're different depending on whether you're using A or B, whether your theta is the A or the B. Opposite and adjacent are relative to the angle that you're working with. So sine of A will be opposites over hypotenuse. So sine of A is A over C. But if we write sine of B, opposite B is side B. So sine of B is B over C. So we've got to be careful. So I just wrote in terms of opposite, adjacent, and hypotenuse. Okay. So one of the things that we want to avoid, since our answers are going to come out long, our calculator is going to be giving us long numbers for our answers. We don't want to use rounded answers in our calculations. We want to leave most of this up to the calculator. So one strategy that we've gone over before is if you have one angle, as soon as you have 2 angles, subtract to find the third angle. I also want to take this opportunity to clarify what I mean by show your calculations. When I say show your calculations, I mean write what you're going to type. If you have to write a setup before you write what you're going to type, then do that. If you could just write what you're going to type, just write what you're going to type. It's the easiest way to see where you make a mistake if you made a mistake. So strategy 1, if you have two angles, subtract to find the third angle. We have this angle B. We have the angle C is 90 degrees. So B is 57.8 degrees. And side C is 18.7. So we're going to subtract. A is 90 minus 57.8. I'm going to write this down because this is what I'm taking to my calculator. It's just subtraction. Nothing fancy going on here. Don't even have to worry about rounding. 32.2. We are a third of the way done. Then we're going to label it as degrees to make sure that this is clearly an angle and not a side. And then we're going to put a box around the answer. You know, I'm not trying to convince you to put boxes around your answers. You could also summarize and put one big box. If you're like one big box style, that's also cool. I guess I'm an individual box guy. The next thing we want to notice is that we want to try to use the given information as much as possible. Now, 32.2 has not been rounded off. That's like the whole thing. That's all we get. So we could use that too. But let's just practice using the given information. The 18.7, what would we label that in this triangle? Hypotenuse. It is opposite the right angle. The little right angle box is pointing right at the 18.7. This is the hypotenuse. There's only one, and we also want to remember that that is the biggest side. So if we get a side that's more than 18.7, we fucked up. And we need to fix it. So we got a hypotenuse. Now, if I'm going to use the 57.8, what is A relative to the 57.8 degree angle? Adjacent. So A is adjacent to the 57.8. I've got a hypotenuse. A is adjacent to 57.8. So which trig function am I going to use? Cosine, because I've got adjacent, hypotenuse. and here's my angle. So I could say cosine of 57.8 is adjacent over hypotenuse. Here's the tricky part. This is not the only thing that we could use to find A. It's just the first thing that occurred to me because those are the two pieces of given information. So here's the other tricky part. We don't necessarily have to write this down. I said write down what you're going to type. So we want to solve for A. We want 18.7 times cosine of 57.8. A is being divided by 18.7. So we could think multiply both sides by 18.7. In between equations, it's best to write an arrow, not another equal sign. So this is what I'm going to be taking to my calculator. So I'll put 18.7 cosine of 57.8, close parentheses, because I'm trying to build good habits, and hit equals. Now I need three significant figures. So I write 9, 9, 6 will be the last one. And after the 6 is a 4, which says stay. So I'll write 9.96 centimeters. If you don't write centimeters after it, I take off 1,000,000 points and you go all the way back to elementary algebra. Kind of a bummer because we don't offer elementary algebra anymore. One of the things that we want to be careful about is when I'm calling for significant figures, notice that this is less than 10. So I'm going to 9.96 and our hypotenuse is 18.7. So we have to get a different view of what the same magnitude is. 3 significant figures is different than the nearest 10. This is not the only thing that we could have done to get A. It's just the first thing that occurred to me, and I like it because it uses the given information. At this point, I've got 2 sides, and I can use the Pythagorean theorem to find the third side. That might be the first thing that occurs to you. Or you can use the strategy of only use the given information. This 9.96, that's been rounded off. I'm not sure how to use the answer key on my calculator. I'm going to be safe. And I'm going to say B is opposite to 57.8. And 18.7 is hypotenuse. So using just the given information, we can go after B and say the sine of 57.8 is opposite over hypotenuse. And we got the same style of solving. I spelled B wrong. Here's the other reason I like this. So I can grab my calculator and just say, hit second, enter, and change cosine to sine. So it's less typing. 15.8. So we were able to solve this triangle using just the stuff that we were given. We don't always have that option, but when we do, we might want to exercise it. The good news is that there's a lot of ways that we could have got at these values. The bad news is there's a lot of ways we could have got at these values, and we have to pick one. So you need to think about what your strategy is going to be when you sit down here on Thursday. Actually, you'll be sitting down an hour early. So when you sit down here an hour after that, think about what your strategy is going to be. I'm going to only use the given information. I'm going to practice using my answer key. Because for one thing, if we have the 9.96, let's suppose, let's go back through my history, did that. Then we did the cosine. We have this 9.96. Let's say I want to use the Pythagorean theorem. So the Pythagorean theorem would be, to find B, would be B is the square root of C squared minus A squared. So that's how we rearrange this. B is the square root of C squared minus A squared. So I could say B is the square root of C squared minus A squared. Now, the 9.96 is what we're writing down. That's the value of A as far as this piece of paper is concerned. But it's not the value of A as far as our calculator is concerned. Our calculator is like, oh, no, there's more to it than that. Fortunately for our heroes, there is a 9.964786363 button on our calculator, but only right now. It's the ANS button above the negative that's in parentheses. ANS. It won't focus. So if I go second ANS, that button is 9.96. If I do anything else, another number pops up, it's not a 9.96 button anymore. But I can do a square root of 18.7 squared minus ANS squared, and then get the 15.8, no rounding error, because I used more digits. Or we can just be like, oh, I don't like fancy stuff. And type a lot of digits. Eventually, you will know how many digits you need in this calculation so that you avoid the round off error. If you don't know right now, use many. Does that make sense? If you're not sure right now, if you don't just know how many to use, then just use them all. If you want to know how to figure out how many digits to use, practice, wait. Actually, while you're waiting, practice some more. If you expose yourself to a lot more of these calculations, you do the calculations more often, then you will know what to do. You'll just know. A lot of times in math, that's what happens. How will I know what to do? Give it time, you'll just know. Make sense?
I'll be right back really quick, baby.
All right. Any questions? This does not demonstrate all the things that we could have done to get at these answers. It's just some of them. You're going to have to decide on your strategy. In part B, we've got a different setup. I have two of the sides. I'm giving you two of the sides. I've given you two of the sides. What's the first thing that you're going to want to do? What is the first thing that you chose to do? Pythagorean theorem. I was reading all your minds. I knew most of you were thinking Pythagorean theorem. Some of you are like, I'm not going to do the Pythagorean theorem first. I bet you expect me to do the Pythagorean theorem first, but I'm not gonna. I'm not going to be one of those Brittany and Justin wannabes. I don't have enough hair anymore to flip like the goth kids on South Park. So notice that we have A and B. So A is 12.4 and B is 10.2. So Pythagorean theorem doesn't care about opposite adjacent hypotenuse. So I'm just going to use the Pythagorean theorem. That's what you all want to do. Weirdos. I'm just kidding. It's totally normal for weirdos. You got to remember, if you're solving for C, we're not subtracting. So we don't have to rewrite this one. We just have to square root it. So it's A squared plus B squared. So 12.4 squared. I'm just writing down what I'm going to type into the calculator. So 12.4 squared plus 10.2 squared. I'm going to close parentheses, even though I don't have to, because I'm going to use proper syntax. 16.05. The 16.05 says we should round this to 16.1. We're going to write 3 decimal places, 3 places, so 16.1. And this is in feet. If you write centimeters instead of feet, I take off 2 million points. It's 4 million points. Don't worry. This is pinball style. The test is worth 60 million points. It's like pinball escalation. Does anybody play pinball? One person? So like a long time ago, like an old pinball machine, it's like a 100,000 points and you get a free replay, right? This is because in pinball, you can theoretically just bring one quarter and play forever. Or until you get bored. But then new machines would come along and they would just kind of escalate. And so you go to the new machine, it's like, oh, 30 million points for a free replay. And you're like, oh, holy shit, how am I going to get 30 million points? You let go of the ball before you even hit a flipper. It's like bonk, 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 bonk. You have like 10 million points. You're like, oh, all right. So it's just like you multiply by 1,000. All right. So A and B. Now we've got C. So now we have many options. Good news, we have many options. Bad news, we have many options. I want to use just what I'm given. So if I want to say find angle A, what is the 12.4 relative to A? Opposite and the 10.2? Adjacent. So I've got opposite, adjacent. What trig function am I using? Tangent. So I could be like, oh, tangent A is opposite over adjacent. This is just the setup. I like to write down the setup, and then I say, what do I have to do to get at the angle? I have to inverse tangent. I'm looking for an angle, so inverse tangent. It might be that this is the only thing that you write down. Because in your practice, you preloaded writing angle equals tangent inverse and then opposite over adjacent. It might be that in your practice, you are writing down the ratio first. So tangent inverse, opposite over adjacent. 50.55, so 50.6. As soon as you have two angles, subtract to find the third angle. If you want to be fancy, you could just tangent the other way around. But as soon as you have two angles, subtract to find the third angle. If you wanted to be fancy, you could just flip over the 12.4 and the 10.2. 12.4 is opposite A, 10.2 is adjacent to A, 10.2 is opposite B, 12.4 is adjacent to B. So maybe you're like, oh, I'm going to be fancy and say tangent of B is opposite over adjacent. Any questions? So what's the difference between problem B and problem C? What's changed between these two problems so far as given information goes? Why are these problems different? What's different? Yeah. In C, I know the hypotenuse. In part B, I know two sides, don't know the hypotenuse. In part C, I know two sides, one of them is a hypotenuse. So that makes it a slightly different problem. In part A, I had an angle and the hypotenuse. The problem that we had last time, we had an angle, not hypotenuse. There really are only 4 problems that I could pick to put on this problem. There's only 4 variations of this problem. Angle and hypotenuse, angle and not hypotenuse, not the two sides, not hypotenuse, two sides, hypotenuse. There's only 4 problems that I could do. 4. I hate doing this because it's like, I look like one of those douchebags, like, oh, 4 problems. I feel like this is like a rich douchebag maneuver. Not a rich douchebag, just rich. I'm just rich. It's the other one. I'm just kidding. Teachers are fucking loaded. I'm just kidding. We're loaded. Means something completely different in Texas. We're loaded. I'm just convinced because Texas is like, oh, we gotta give teachers guns. I'm like, oh, those fuckers have not met me. I'm like, oh, dude, I cannot see across the room. I don't know how far shit away is from me. And you want to put a weapon in my hand? Please. Please. Anyway, what are we talking about? Oh, yeah. There are 4 problems. There's only 4 problems. It's either you got the hypotenuse or you don't. You've got an angle or you don't. There's only 4 problems. Like in tic-tac-toe, how many opening maneuvers are there in tic-tac-toe? Not 9. Because a bunch of them are the same. You can go in the center square, you can go in the corner, or you can go on the side. There are 3. There are 3 opening moves. Because the side move, you could, if you use the side as an opening, first of all, that's the only way you could possibly lose the game. Open in the center, in the corner. If the second person goes in the center or the corner, then the game is a draw. You could just stop right there. If you open in the side, you can lose. If someone opens corner or center and you go into the side, you can lose. That's it. Tic-tac-toe is solved. There's no point in playing tic-tac-toe. It's just to find out who knows how to play tic-tac-toe. You need 2 moves. Did you go on the side? No. All right. This game is over then. You know what I mean? There are only 4 problems I can put in this solving triangles. Practice those 4 problems. You have versions of it. You can also come up with your own. There's also the one where I give you the non-triangle one. I am not doing that on Thursday. I don't know why, but every time I do that on Thursday, it just fucks everybody up. So I'm just not going to do that. It's just messed up. And people go, oh, what the hell's going on? I was done with this test like 40 minutes ago, but I can't figure this one out. It's like, well, one of the answers is that there isn't an answer. I'm like, oh, fuck you, Leach. They don't say it out loud, but I can hear it in their minds. All right. The other thing that I wanted to go over is the reciprocal ones on the back here. The reciprocal ones on the back. The first, so notice I split this out into 2 parts. The upper part is just plug it into your calculating machine. The second one is use inverse trig functions. So we need to know the first 3, no problem. Just type it like you see it. Right? Tangent 54. 1.37. You don't even have to write down what you're going to type into your calculator because it's like just literally the question. I'm not going to make you write tangent of 54 again. Just write down, just plug it in, write down your answer. Now this one, this messed up because you might not have a cotangent button on your calculating machine. You know that cotangent of an angle is 1 over the tangent of the angle. The important thing here is that we have the angle. So cotangent of 54 is 1 over the tangent of 54. That's just using this up here. We have the angle, so we just do 1 divided by tangent 54. Question? Oh, we would. Very good. You found my carefully planned mistake. That's 0 points for you, minus 1,000 points for everybody else. I'm just kidding. It's minus 2,000 points for everybody. I'm just kidding. I did not round properly. So we want to do 1 divided by tangent of 54. When we have the angle, we do 1 divided by tangent. And you could type it just like you see it. 0.72, I'm not going to do this again, 0.727. I prefer writing a leading 0. You might not want to write leading zeros. I don't know which one looks good to you aesthetically. That is an aesthetic choice. Whether you put 0 point or just put point. If you just put the 0.727, that's fine. You just have bad taste in numerical aesthetics. Just kidding. You have terrible taste in numerical aesthetics. So on this first half, it's going to be 1 divided by trig function of angle. When we're undoing that, right? When we're undoing that, when we're looking for the angle, the inverse trig function has to go second. We do the 1 over first, then the inverse trig. So over here, we've got cotangent of x is 2.46. Cotangent is 1 over tangent. So before we do the tangent inverse, we've got to do the 1 over. We've got to flip everything over first. So this means that tangent x is 1 over 2.46. So going in this direction, instead of doing trig function, then 1 over, we have to do 1 over, then trig function. So x is tangent inverse of 1 over 2.46. Any questions? Just told you how to do those 3 problems, 6 problems. But I want you to see 2 things going on. You do the trig function, you do the reciprocal. Here we did the trig function, tangent of 54, then we did the reciprocal. That's the order of operations. Down here, we need to do the reverse, the inverse operations in reverse order. So first, we 1 over the 2.46, then we invert tangent. How's that, okay? I know today was a lot of me, because I wanted to go over strategies. I wanted you to hear what I think you should do on the test that I'm writing, that I'm scoring. So I am an expert on this particular test. I know the dude that wrote it. Sure. I know that guy. This is what he looks for. So that's why that's why there was a lot of talk. Any questions? Comments? Slide them. We're going to crash it on Thursday, yes? I love the false enthusiasm. Yeah. There was much rejoicing. All right. That is it for today. Wow. That's going to do it for today. I will see you all on Thursday. The first hour, I mean, talking about new stuff to distract you. So don't fall for that. First hour is going to be some new stuff. We're going to expand into other quadrants. That's it for today. I will see you all on Thursday. Everybody have a good couple of days, and thanks for playing.